everybody. I am on derivative graphs. This one is an exam gen worksheet and it has 11 questions on it. It says worksheet like 6777 in the corner. I'm just gonna do like the first 5. This is definitely one of those worksheets where you want to try them first and then, come back. I'm going to do the first 5 right now, and then I'll post the answer key to this Tuesday. So you can, work it out, see if you can get them right. All right, number 1. All right, I said it all in my last video. I'm saying it again. It's really important to know what you're looking at. Am I looking at the graph of the function or am I looking at the graph of the derivative? Because how I answer the question is definitely going to matter based on what I'm looking at. So the graph of the function, sometimes you'll read it here, sometimes it'll be labeled nice and clearly for you, but make sure you know. Which of the following could be the graph of f prime, the derivative? So I'm looking to pick the derivative. Now, I can go through some basic stuff. This original function is a degree of 4. And so I would be looking for a degree of 3. That allows me to get rid of the original function has a positive leading term, so my derivative has to have a positive leading term. And I have it narrowed down to D just on that. Okay, if I look more specifically, I can see things like, okay, the graph is decreasing, so the function is below the x-axis. Then there's a slope of 0. Derivative is at the x-axis. Then there's positive slopes. Then there's a slope of 0 again at the x-axis. Then there's negative slopes for a little bit. Then it's a slope of 0, positive slopes the rest of the way. I mean, that's a lot of detail that I didn't need to go into, but just, sometimes you do have to know all that. That one, we got it narrowed down to just by degree and leading term. All right, 2 is a review question from this packet. This is definitely the definition of derivative. So when I'm looking at that, I should be thinking f prime of something equals 2. Now, it's clear to me just looking at it, it's got a 3 plugged in. What do they want to get you on? Let's see what the choice is. The function f is continuous at x equals 2. Well, what is this asking then? Sorry, I should read the original question first. If the limit, blah, 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 equals 2, then which of the following must be true for function f? I wrote down the answer, so this is going to be answer B. We didn't get a lot into continuity, so, part A you probably might be stuck on, only because we haven't talked about it a whole lot. F of 3 equals 2, we can't say that. By chance, could the function at 3 be 2? Sure, but that's not something we know based on what's given in the problem. Could f of 0 be 2? Sure, it could be, but that's not, it's saying what does this allow you to get? This allows me to know this piece of information. The derivative at 3 is 2. Okay. Next one. Now in number 3, I'm looking at the graph of the derivative. Very important to note. Because if you think that this is the function, then you would probably pick choice A to be the derivative. If this was the function, then choice A would be the derivative. That's why it's important to know what you're looking at. This is the derivative, I need to pick the function. Okay, which of the following must be the graph of the function? Okay, so if the derivative is a diagonal line, then the function would have had to have been a parabola. Like this is a degree of 1. So knowing the power rule, that means we went down 1 to get there. So the degree of f has to be 2. So I'm looking for a parabola. That theory allows me to cross off choice A. Next thing, the leading term has to be the same between the function and the derivative. So if this guy has a negative leading term, how do I know that? It's going down. Then the function has to have a negative leading term. That allows me to get rid of B and C. So now I'm down to D and E. Well, it has to be E. Here's why. This is where I'm following a little bit more closely as to what's happening. The turning point has to happen somewhere to the left of the y-axis. So that's matching up with where that is. It's like I have positive slopes. Yep, I got positive slopes. Then I have a slope of 0. Yep, that's where the turning point is. And then I have negative slopes after that. Okay. Does the same thing happen in D where you have positive slopes, then 0, then negative? Yeah, it's just not happening in the right location. This guy's hitting the x-axis somewhere to the left of the y-axis. Number 4. Okay, we have to think back to our chart that we made. So this is a cusp. And the cusp it came up at the last part of that little chart we made on page, I want to say 18, 17, 18, somewhere in there. The derivative does not exist there. So if the derivative does not exist at a cusp, then I can cross off choice B and choice D. Because choice B and D have a value there. They are a smooth curve right through the origin. So they're saying, if I look at graph B and D, they're saying, oh, the derivative is 0 there. The derivative is not 0 there. The derivative doesn't exist. And in graphs A, C, and E, you see an asymptote in all those cases. That's a good graph for the fact that the derivative doesn't exist at 0. Okay. I jumped ahead because I know this problem, so I jumped ahead. Going back, this is the function we're looking for the derivative. Okay. So I got it down to A, C, and E. This portion of the graph is going down. So that means the slopes over here are all negative. The second portion of that graph is going up. So those slopes are positive. So when I'm trying to find the correct derivative graph, I'm looking for something that is below, then above. Only one of these is below, then above. Choice C. Okay, number 5. This is the graph of the function. I'm looking for the graph of the derivative. Okay, if I were to draw in a tangent line right here, I was leading to this last week as I was filling in that chart. If I were to draw a tangent line in right there, it would be a vertical line. So the derivative doesn't actually exist at A and negative A. If I were to draw in tangent lines right there, they would be vertical, and the slope of a vertical line is undefined. So I'm looking for the derivatives. Choice C doesn't make sense. In A, B, D, and E, you can see those little dotted lines, okay, meaning that you're not going to have a value there. Those are asymptotes. Okay, moving on. I want, this guy's increasing, so I want positive slopes. Then I would have a slope of 0. Then I want negative slopes. So I'm looking for positive numbers, then at the origin, and then negative numbers. A is not doing that. A is going below, then above. B is not doing that. B is below, below. E is not doing that. E is above, above. I want above, then 0, then below. D is the correct choice for that derivative. Okay, I'm going to let you guys try the other ones on your own. I think that graphs of derivatives can be very difficult. I think certain things can be easy about them. I don't think every single question is super impossible, but I do think that there are some really hard problems when it comes to graphs of derivatives. It's one of my absolute favorite units to do all year. Not necessarily via e-learning, because I can't read people's faces and call on people and take questions immediately. So that's a little bit of a struggle for me. But if you have any questions, just, send an email to myself or Mrs. Faber, and we will get back to you as soon as possible. If I have to make another video, if I have to go over something again, I will. Just let me know. And I hope everybody's doing well.